put it in the so what does WhatsApp doesn't respond. Let it be. You can always share the link afterwards. WhatsApp close. Tag is hot. Sorry, just give me 1 second. Out of just a very brief minute. So, anything you guys want me to recap from the previous one? So, these were just basic introduction. What we'll do today is, so we'll look at some basic statistics. So, some of you may have already attempted this. So, it's kind of a recap for you. But for others, so this is going to be possibly the first time you're attending. So, we'll again go in detail. So, there is no hurry with this topic. WhatsApp seems to be stuck and is causing. Finally. Okay. All right, guys. So we can start now. So the stream is has already started. So just checking, am I audible? Can you guys hear me clear? And can you guys see the PPT? Is everything fine? Is everything fine as and for PPT stuff? Understand a lot of things can go, but yeah. So any exams that are coming up currently, or some things that I may not be aware of? I'm asking just so that like we can make some MCQs or PYQs of mocks based on those. Any exams that are coming up? Gate has opened. That is one update you guys need to know. And any Clin.Psy exams that are coming up, do let me know in the chat. So for now, let's start with the class. Okay. So we left off where Frida had kind of almost reached the peak, which literally means there is going to be a cognitive check based on whatever we saw in the last class. So I'm gonna show the screen. So you guys have just could give you 1 minute for this particular task, or maybe 2 minutes for this particular task. So what you have to do is you can have to start from the bottom as in the most lowest row. So there are rows of ice blocks, and you're supposed to help Freud or Frida climb them, right? So remove all those false ice blocks, so not the real ones. You will not be able to remove the real ones. So, and then keep going up as as you progress, right? So you guys have 2 minutes. Let's see if you can get this. So let me know if you have completed, and we can start. Camera lag is still there, but so each row has just one wrong answer, which is what you're supposed to click on. So this is based on what you read so far. So have possibly another minute. One minute, 20 seconds are up. If you guys have completed, let me know. All right. So while you're at it, I'll start from the bottom row. Okay. So we have seen the light-based double screen experiment in physics. It is an example of observed effect. I would say light is actually not conscious, but still have some effect. It's true. So Sigmund Freud based his entire theory on psychoanalysis. It is not naturalistic observation. It is case study, right? So this is about commitment to obtaining and evaluating, which is free from bias. That would not be accuracy. That would be objectivity. This is also wrong. And scientific method first involves pursuing the question, and then you have the hypothesis formation. This is wrong. And natural sciences model developed or employed the nomothetic yes, which is true. Social sciences was based on idiopathic. So it is idiographic, not idiopathic. So I explained the difference in the previous class too. That is a difference. And for the last one, Darwin did write the book Descent of Man and Selection in relation to sex. So that is true. Darwin's theory of natural selection was the first blow. No, it was considered the second blow. That is false. The third blow was obviously Freud's own theory. Okay. So hope you guys were able to reach the top without mistakes. So now at the peak, so Frida, go with the storyline obviously. So Frida decides to stay in the dreamscape or Thanatos a little longer. That is how we are able to still have the class. So the next topic is going to be about statistics, right? So this was just a small iceberg. It was just intro to psychology, some uh, research method intro, but we'll look at that in depth after a brief intro to statistics. Okay. So how many of you have statistics as your major weakness? As in even the basics of statistics, mean, median, mode, variability, variance, standard deviation. Right, two people have raised their hands. You can put in the chat. All right. So Freud says at this rate, if you're doing so well, you literally conquer all of the syllabus, which is literally all the peaks. Hopefully so, we are expecting the same. But the problem is now with this journey, they have a hailstorm happening and a lot of roadblocks. So a lot of people may have already played this episode. Still, we are having a recap of it. They're supposed to survive the hailstorm to reach the center of the forest, which also happens to be the peak, but there are a lot of fallen trees, right? So you're supposed to clear them. So you have 1 minute. Lag is anyway. So you have 1 minute and try to unlock all this trees and unlock the PPT. So I'll start explaining or discussing after a minute. So those who raise their hands, let me know if you have any doubts or questions in the chat. Not be able to see the YouTube chat, but I'll be able to see the Teams chat. Do let me know. You guys have 10 seconds. If you're done, maybe hit a thumbs up or something. Start. 1 minute is up. So this is about levels of measurement. Okay. So something you have already seen and heard, but if you were to ask who gave it, so it is not Gauss. Gauss is related with normal curve. So we have S.S. Stevens in 1946. So he gave 4 levels of measurement. So you have nominal, ordinal, interval, and ratio, right? So someone gave me this acronym NOVAR. So if you've seen Spider Novar, which is a series, so you should be able to relate this. So first one, N, is the nominal scale. The nominal scale has the Latin root name, so it does not have any magnitude at all. Okay. So it is categorical in nature, or somewhat you could say qualitative in nature, right? So it is only categories and it does not have any magnitude, or there is no quantitative things to it. Even if you use numbers here, numbers only mean name, right? So it is literally calling someone as 1, 2, 3, or 4, but not assigning any value to it. So jersey numbers of football players, cricketers are a typical example that is usually given, right? So for you to collect nominal data, you should make sure the categories are mutually exclusive and exhaustive. So you may be asking, what does exhaustive mean? So let's discuss exclusive first. So if you have a data collection instrument and you're collecting, let's say, some demographic variables like religion, right, or gender, so you should have exclusivity in them. So for example, if one belongs to, let's say, the male gender, they should not be able to check the female gender as their gender, right? So that is exclusivity. So people should belong to one but not the other category. But exhaustiveness is about listing out all the possible categories. So if you were to give the city you are going to or you were from, right? So the city you were literally from, so you should give all the list of cities in India. So if you're considering India as your population, so you should not leave out any city. So it should be exhaustive in the way that people should be able to pick that option as a category, right? So you may say, in my research tool, I will use possibly a blank and let people fill there. So the drawback with that is there may be spelling mistakes, people will fill differently, and you may end up with 2 different categories of the same instance, right? So that is how when you're collecting data, particularly nominal, should be exhaustive and exclusive, the other way around. So I hope this is clear. So nominal data does not have any magnitude. So other than that, what statistics do we use here? So in terms of descriptive, so I'll tell you what is descriptive and inferential. We use literally frequency counts. The number of times people have chosen this as a place of birth, or number of times people have chosen a particular religion as their faith, right? So those are all frequency counts. So that is possible in nominal. So you cannot do anything more than that. You cannot do mean, you cannot do median, or mode is possible because mode is based on frequencies. The mode would be the only central tendency. So I'll tell you what are the central tendencies in the upcoming one. In terms of inferential statistics, what inferential statistic do you know can be applied here? Those who are on Teams, can you put in the chat? So what inferential statistics can you actually use when you have nominal level of data? Chi-square, good, right? Which is literally of the same thing where you have to have exclusive data, right? So one should not belong to the other. So if chi-square is very, very small, what is the alternative? As in each cell, you need to have at least 5 frequency counts. If that is really less, what else can we use instead of chi-square? All right. So anyway, it's a bit complex. So it's called Fisher's exact test. Okay, its correction can be done. Fisher's exact test is okay. So we'll discuss those in further classes. Now moving on to ordinal. So you have magnitude also here, but the magnitude is not equally distant from each other, right? So it is in order of some value, which is magnitude. For example, ranks. So if someone has gotten first rank, second, and third, so it is just based on their marks, but the difference between rank 1 and rank 2 and 3 and 4 and so forth is not equal. So rank 1 may have gotten 90, rank 2 may have gotten just 89.5, but rank 3 may have gotten only 85. So there's 5 mark difference here, there's just 0.5 difference. So they're not equidistant. So the typical example here is rank. Okay. So what central tendencies can we use here? We can use median. Right? So we'll talk about what is median, what is mode also. So in the next slide, it will be much, much easier for you. So other examples here are your Likert scale. So you may think Likert is actually interval scale. I'll tell you what is interval, but Likert is actually by exact definition an ordinal scale. So it is an ordinal scale because we assume things may be equal distance, but it is not so. So for example, you have strongly disagree, disagree, neutral, agree, and strongly agree, right? So what is telling you that all of these had equal distances between them? So if you say strongly agree is here and agree which is here, what makes you think the distance between neutral and this the same as these? So it is not so, we just assume it, right? So that is why Likert scale is ideally in ordinal, but we treat it as interval where apart from magnitude, so we have equal appearing intervals or distances. So if you have 1, 2, 3, 4, and so forth, all of them have equal distances. But if it were rank, they may not have equal distance. So in interval, you have equal distances, and we have something called a zero. Okay. So which is arbitrary, or you could say a pseudo, or you could also say it is not a true zero. Okay. So in ordinal scale, we don't use zero at all. Maybe we can use it as a nominal level variable to include there is nothing, but zero doesn't make any sense on ordinal scale, but it does make some sense in interval scale, but it is not a true zero. It is arbitrary. It is just for convenience. So most of our temperatures, I'm saying most, but not all, most of our temperatures like Celsius and Fahrenheit, they have arbitrary zero. Again, as I said, arbitrary means we have given it based on convenience. So in terms of Celsius, it is the melting point of ice or freezing point of water, however you want to have it. So that is the zero that we have on temperature. Right? So here we can do addition. So hence, you might be tempted to use mean here. So mean would mean you would have to divide the total by a particular number, which may not be making sense in interval scale, but we still do it to get some sort of a typical value, right? So mean is ideally possible only in ratio scale, but for everyday practical purposes, we do use mean here. Okay. So ratio scale has an absolute zero, which means this zero represents a total lack of whatever we are measuring. So if you're having a very highly sensitive weighing scale, and in that weighing scale, the quantity's weight is zero. That means there is literally nothing on that weighing scale, like zero molecules on that weighing scale, on top of it, that right? But you may be surprised to know a particular temperature is considered under ratio scale. We saw temperatures have a arbitrary zero, for example, Celsius, because it is the melting point of ice, and there are degrees below them, 10 and somethings and all, right? But Kelvin, on the other hand, is defined as a particular temperature at which molecules have zero kinetic energy. So that is why that zero on Kelvin is an absolute zero, right? So here we can do division, multiplication, even squares and square roots. So that is why you can say 100 is twice of 50, right? So typical examples here are height, weight, number of objects. So if it is zero, there is zero number of objects. So you could even say rupees to an extent. So on interval scale, we usually bring IQ. So if on an IQ test, a particular, let's say a child gets zero, does that mean the child has no intelligence? So here's my question for you guys. So a child gets zero on, let's say, an IQ test. Does it mean the child has literally no intelligence? So what does that mean instead? Right? So your measurement is unable to go below zero and measure certain things. So intelligence is defined as ability to adapt effectively to the environment and such. So eating, breathing, all these are also minimal intelligence things. It does not necessarily mean you're solving a complex problem. So even taking care of yourself, right? Adaptive behavior are also related to intelligence. So the child is able to eat, take care of oneself without falling over and stuff. That is also intelligent behavior. So dogs are known to be intelligent to an extent, but dogs will obviously get zero on an IQ test because they cannot verbalize, they cannot even do exactly what they are asked to do in terms of solving puzzles and all, right? Doesn't mean they don't have intelligence. They do. It is just that our scale is not sensitive enough for it. So that is why IQ is on interval scale. Okay. So now back to this Likert scale issue. So we do use Likert scale as an interval level data, right? So it is only possible when we have several items of Likert scale. If you have just a single item and you just say strongly disagree to strongly agree with neutral, disagree, and agree in between, it is just a single item. You cannot do anything more than that. That will be absolutely treated as an ordinal scale. Even if you have several, like let's say 100 items, it is still ordinal scale, but we assume they have some sort of equal intervals. So strongly disagree, strongly agree. We don't know how extreme that strongly disagree or agree is, but at least when we have neutral here, agree and disagree here, we can kind of arrive at a conclusion. Agree and disagree may kind of be symmetric, right? So we don't know how symmetric strongly disagree and strongly agree would be. But if we have several data points, like 100 or more than that in terms of items, according to a theory called central limit theory, the more you collect data, the more the data surrounds the central tendency or the mean, right? So very few strongly agree or strongly disagree responses might be there. So you assume that strongly agree and strongly disagree is also the same as the distance between neutral to agree or neutral to disagree. So it's an assumption. Okay? Because you are increasing variability, variability means the amount of differences or different scores or responses you get. Therefore, the assumed ordinal behaves as an interval length. Any doubts or questions in this? So typically, ideally, by pure definition, Likert scale is ordinal, but we treat it as interval for these reasons. Can we move forward? You guys have another minute. So we'll be looking at central tendency. Okay. So you guys have a minute to unlock this slide. We'll begin the discussion after a minute. You guys have 20 more seconds. Anyone done? Okay, 1 minute is up. Is it me and I'm not able to see you guys action? Something else. If anyone is done, just maybe react so that I can see if it is on the slide. Done. But I'm not able to see the reactions actively. But it's okay. Fine. So we're talking about measures of central tendency. So far, we've saw about nominal, ordinal, interval, and ratio data. So if you want to talk about one particular representation for your entire set of data, that is given by your central tendency measures. So which are literally your mean, median, mode. And there are a lot of means, but for current purposes, we'll use arithmetic mean. Right? So dispersion and central tendencies are together considered part of your descriptive statistics. Right? So because they describe the population or even your sample in terms of what is the typical value of this distribution and also how much other values differ from this typical value. So the typical value is this, and how others differ from this typical value is your dispersion. Together they are the descriptive statistics. Okay. So the common measures of central tendencies, mean, median, mode. They provide a single summary, as I said, the typical most value. The measures of variability we'll be discussing in the next coming slides. So the common things are these. So if you draw a frequency distribution curve, the one at the peak and the value that corresponds to it on x-axis is usually your mode. Okay. So because that is the most frequently occurring data point or the most frequently occurring value. So this could be for nominal level, this could be for ordinal, even interval, as well as ratio. So mode can be used for all. But if you have nominal level data, you can only use mode. Fine. So this is for ungrouped distributions. So when you have group distribution, so what is a group distribution in the first place? So group distribution is where you have class intervals. So instead of just 1, 2, 3, 4, 5, 6, 7, 8 as individual data points as raw data, you have 0 to 10, 10 to 20, and such things. Okay, so if one such category has the highest frequency, we use the midpoint of this class interval, which would be around 15. Okay, so that would be our mode in case of group data. Any doubts, questions on this? We not. As I said, when you have nominal level data, that is the only possible thing you can do. So when it comes to median, so this is typically used when you have ordinal or something above in terms of levels of measure. So median represents the exact midpoint in your frequency distribution. It can be here. So in a perfectly symmetric one, so you will have the midpoint as the mode also, which is also sometimes the mean, right? So median is literally the midpoint of a data. So if I have a data point of 1, let me change to have a data point or data set 1, 3, and 5, and I've arranged it in ascending or descending order. The midpoint is 3. Okay, so 3 would be your median, fine. But if you have even number of data, 6, and I've arranged it again ascending. So these two together will be your median. So what you will do is you will add them, divide them by 2, you will get something like 4. That becomes your median when you have n as even. So the typical formula goes n plus 1 by 2 the term when you have odd number of data, right? It literally changes when you have even number of data. So when you have even number of data, you have n by 2, that term, and you add n by 2 plus 1 term. Actually, the next term, both of them are added, and then you divide it by 2 to get your median when it is even. So this is something you already know, so let's not spend much time. Change the size. So it is also called the percentile 50. So we'll talk about what percentiles are. So percentiles are literally points on your x-axis. Okay. So at or below that point, you have certain percentage of data. So hope you guys know what is percentage, because I don't want to go into that. So for example, if this is a point on the x-axis, a particular value when it is arranged ascending or descending, okay? If this is a point on it, the number of cases below it in terms of percentage will be your percentile, the 50th percentile in case of median. Okay, so that is what is percentile, and median happens to be the exact midpoint. So it is the 50th percentile. We'll talk about something called quartile. So there also median will be relevant. So, but for now, we'll unlock the rest of the things. So when you have mean is more sensitive. So we'll talk about mean. When you have very extreme scores, a lot of extreme scores are there in your data set. So that means these also impact the central tendency if you calculate mean, because mean considers everything. Okay. But median remains the same despite whatever you use. So despite no matter how many extreme scores you take, it remains the same, right? So let me give an example. So the same thing, 1, 3, and if I had very extreme scores, 0 is kind of an extreme, but not so much from this. And here I had 1000, right? The median still remains 3, does not change drastically. So that is why when you have very extreme scores, we go with median as the ideal central tendency measure. But if your choice is to represent the entire set of data, let's go back. So if you want to represent the entire set of data and your data is not too extreme, as in not many extreme scores on this and this end, then you represent the entire set of data using mean. So you literally add all the values that you have multiplied by their frequency and you divide it by the total number of data points. Thereby you get mean or arithmetic mean. Okay. So this is very important in inferential statistics because we'll be testing mean differences. So we'll also be testing how each individual data point varies from this particular central tendency where we have variance and such. Okay. In terms of negative deviations or extreme positive deviations, we still go with median. And one more thing, when you calculate mean, and you find out the differences of each individual score from the mean, if it is like this and the central line happens to the mean, the number of negative deviations, as in negative differences, if this is 10, right? So there are so many other values like 5, 7, 8 and all. So here you have 11, 20, maybe 15 and so forth. So these are negative deviations, these are positive deviations. So if we add this and this together, they will equal each other. As in, if you add the positive and negative, you will get a sum of 0. So that is one more indication that your calculation is appropriate. So as I said, when you have very extreme scores, it's better to go with median. And so any doubts, questions in this? Full set. Okay, so any thoughts, questions, doubts? What I think we have actually. Okay, I'll see if the lag is better if I show only content. Seems to be way better. All right. So you guys have another 30 seconds because you just have 4 blocks here. So try to unlock this and clear the trees. I'll tell you what we're discussing. Done. So we already talked about central tendencies. Now it's variability. So variability is nothing but how much each individual score varies from the center. right? So we know central tendency is a summary. The summary means there's a single best, but it doesn't represent everything. So there are scores which are very different from the mean or median or mode. Okay? So variability expresses how the scores or the total set of scores differ from each other, or how they gather together. So how they scatter or cluster together. So that is what variability talks about, right? So it does not specify how far a particular score diverges from center. Not all the measures of variability talk about this. And also it talks about it in terms of the overall variability, not for an individual score alone, right? So it also does not provide what is the shape of the distribution. It does not tell us that. It does not also tell us the level of performance. So that is better given by your mean, median, or mode, which are central tendencies. So if you want to know how good a class performed, you talk about the mean value. That will be a better measure. But variability does not say how much your class has performed, how well they perform, right? So we have a lot of variabilities, but there are four common ones. You have range, and you have semi-interquartile range, which is also quartile deviation. Then you have variance and standard deviation. You also have something called average deviation, but we don't typically use that. Okay. So now, so we have a minute. So let's unlock the slide one so that we can help characters move forward. So these are the types of variability that we are talking about. You guys have a minute, unlock the slide, and also test how much you already. 30 seconds up. Right, so slightly beyond a minute, but that's still fine. All right, so range, it is not sensitive to the, it is actually sensitive to the extremes. So actually you get the scores, the highest minus the lowest. So that is the range. It is just pretty much descriptive. You just like get what is the overall value range. So if you have 0 as the lowest score on a test and the highest score was 9 out of 100, 0 to 90 minus 0, that is your, okay. So it is not sensitive to the total condition. So then we have the interquartile range or quartile deviation kind of this. So quartiles are something you may have to understand, right? If this is a distribution, quartiles are points which divide the whole distribution into quarters. Quarters means 4 parts, right? So based on this, how many quartiles do we get? Any thoughts? Can you guys like guess how many quartiles do we get? Or how many quartiles are required to divide into 4 equal parts? Yeah, so hope you guys don't think it's 4 because quartiles. It's pretty much a very rookie mistake, right? So you get three quartiles, Q1, Q2, and Q3. Okay. So I'll tell you right off the bat, Q2 is the same as your median. Okay, because this divides the whole distribution into two equal halves. That means this is the 50th percentile, or this is the midpoint of your distribution, which is also what median is. That is a typical definition of your median. So this Q1 is 25th percentile, P25. Okay, so this is P75. That means below this there are 75% cases. Below this one, Q2, there are 50% cases. And below Q1, there is 25% case. Right? And from Q1 to Q3, sorry, this should be 3, there is 50% cases. Obviously, this is 25, 25, 25, 25. These two sum up to 50% of cases. Okay. So if we talk about just range, this is what we say, but quartile deviation or semi-interquartile range is also this. To find out what is how your, let's say, your distribution varies. So we subtract Q1 from Q3 and divide it by 2. Right? So dividing it by 2 gives you the range. So first you get the range, and now you get the midpoint of the range if you divide it by 2. So that will be something close to Q2. But in most cases, it may only be approximately Q2, but not always, especially when you have skewness, as in if your distribution is not symmetric. So this is not sensitive to extremes of your distribution, right? Because whatever is beyond Q1 on the left side and beyond Q3 on the right side do not impact. It was supposed to be only the middle, so it does not impact. So only the middle scores are considered. Okay, so if you make a mistake, you will get something like this. I hope you guys don't get that very often. So they are sensitive to the presence of very extreme scores, because anything beyond Q1 or anything beyond Q3 is not considered. Okay. So it is better than standard deviation in that regard. So standard deviation is also something we will be discussing. That considers the entire set of scores, right? So with very skewed distributions or open-ended distributions too, so this may be the best measure you will have. Open-ended means there is a possibility of a very high extreme score on either sides. So interquartile range or quartile deviation is what is best. Now, then we have something like deviation score. So this requires you to calculate mean, is given by x bar usually. Okay. So how much, let's say in a distribution, the center is x bar. So how much each x or x1, x2, x3, x4 or so forth differs from this. That is what is a deviation score. That is a single deviation score. Okay. So now a single deviation score does not tell us much, because we want for the whole set of data. So you can add the whole set of data, but that would sum up to 0, because on the negative side, you have minus deviations. On the positive side, you have obviously positive deviations, and both are equal. So you'll get 0. Right? So that is one issue with a deviation score. As I was saying, the deviation score indicates how much variability it is there, not how much. So you'll have very small deviation score if things do not vary very largely from the mean. So scores are very tightly packed. You will have very small deviations, right? So now you could apply some mechanics here to arrive at a overall deviation score, which is called the average deviation. Okay. So before I get into this, you guys have a quick maybe 40-50 seconds to unlock the slide, and then we'll discuss those average wiring and those mechanics. Right? So time starts now, and let me know when you unlock this particular slide. On that. Forty seconds are up. Should be rather easy. All right, guys. So hope you guys are done. 1 minute is up. So I'll start explaining the ones you have. So as I was saying, you have deviation score, which is given by D, which is literally X subtracted from the, okay. If you have a very small value, this ends up as negative. If you have a larger value than the mean, this ends up as positive. Okay. So if you sum all of them, they are both equal and you will end up getting 0. So that is where you apply something like a modulus of the deviation score, where modulus turns all negative values into a positive value. Thereby, you can add all of them and get an average value. But this again does not tell you clearly how much it varies. So a better strategy is to use squaring, then taking the square root. Okay. So instead of applying modulus, we can square the deviation so that the negative values become positive. Okay. The sum of such deviation squared divided by the total number of data points you have is your variance. So deviation is literally how much a particular value differs from the mean. And you add all such values, that is your sigma deviation, and then you square them divided by the total number of values. Okay. So this is your variance. So this is still not your standard deviation. This is your variance. So this is something we have already seen. It is equal to 0. One way is to do the modulus, and other way is to square them. That gives you the variance. Okay. So, but still we have squared units, right? For example, so if the difference is measured in height, so x1 is centimeters and mean is obviously again centimeters. Okay, so the difference score is going to be in centimeter. But when you square them, you get centimeters squared. That doesn't give us much. So how do you get back to centimeters? You take a square root of it. So if you take a square root of deviation, this is your standard deviation, right? So this is what we use in most of our inferential statistics. So note that this formula is for usually the population or whatever given set of data. When we are not concerned about inferential statistics, this is what we use. But when we are trying to compare a sample and the population, so in those cases, we will have to do a correction. We'll talk about that much later, not here. Okay. So variance is expressed as squared units of measurement. That is a flaw. And for correcting that flaw, we literally just take a square root. Okay, so which is called the standard deviation. So this is exactly like mean in a way that it is responsive or sensitive to all the scores in the distribution. Okay. So it is more about the position rather than just the magnitude. And if you have very extreme scores, standard deviation will also be extreme. So it may not be the best when you have a lot of extreme scores. Just how mean is not the best when you have a lot of extreme scores. Here, so far is the main variability measures and central tendency. What does exact position mean here? Oh, this is the difference. So position would mean when you arrange something in an ascending or descending order. So exact position of each of the data impacts your deviation score, which also impacts your deviation square and impacts your standard deviation. So position is literally how far it is from the mean. Okay. So ideally magnitude should also have been mentioned, but I think that was a very bad choice of word. So this is what means by position and it being sensitive, or standard deviation being sensitive to the right. So there's one more comment in the chat. So someone had mentioned for quartile, it ranges from -3 to +3. So it is not the case. -3 to +3 is for your Z scores, which we'll be looking at the upcoming slide. No, not the quartile. So then I kind of may have assumed it for the range. Oh, even for range, where do we get -3? Okay, anyway, so only when you have Z scores, we get minus stuff. So we'll discuss that. So any doubts so far? Guys, that was an assumption on my side. And so we are done with central tendencies and measures of variability. Of course, there are so many other measures of variability keep getting invented and discovered and stuff. All right. So now we move on to Z score. Before we start unlocking, let me say what is the Z score? It is called a standard score, and it is derived from both your mean and SD. Of course, you're also going to get a particular X value, let's say X1, 2, 3, or 4, whatever you're using, that you can transform into a Z score use if you know your mean and standard deviation value. Right? So given that, so you guys have 1 minute to unlock this slide before we move forward. Your time starts now and let me know after a minute. Not taking even a minute. We done? Minute is up. SD, then I counted. Oh, okay. SD. All right. Sorry about that. So now we talk about Z scores. As I said, Z score is also called a standard score, right? So it says the position. So when we say position, how far is it away from the mean when things are arranged in ascending and descending? So in terms of a score, how far is it from the mean? That is what you get in terms of a standard score. It's a relative positioning system, but it helps you compare different samples or different populations and sample and a population and stuff. So Z-score has that ability. I'll give you an example. But before that, it uses the standard deviation as your units. So someone had said -3 to +3. So when you convert things to Z-scores, you have these. So the standard deviation of, let's say, a normal curve when you have Z-score is 1 SD. So we'll again discuss this in detail. But for now, so why do we use Z-scores? We need something that is a standard score for comparison, right? So suppose you have taken two tests from two different uh, institutes. Maybe, for example, you took UGC-NET and you also taken GATE and you've also taken some Clin.Psy exam, right? Or maybe CUET-PG. So you got one score on NET, one score on GATE, one score on Clin.Psy or CUET-PG. So by the way, these are also the exams that we help you with. Just letting you know. So NET you got, let's say, 75%. I'm going to express everything as percent so that there is some similarity. So GATE you got only 56%. CUET-PG you got 80%. Maybe Clin.Psy you got possibly something close to 85. Just assuming, right? So does that mean your Clin.Psy was your best performance? We cannot assume that unless we know how the rest of the test takers scored, right? So that is what gives us the Z score. So we can convert each of these to Z score or even sometimes percentile for us to arrive at how you were placed relative to the rest of the scores or relative to the mean of each distribution. So that is what helps us compare difficulty levels of a test across tests. So it tells us how people performed in different measures. So using Z score, right? So to calculate a Z score, you have your X and you have your mean. So you subtract them just like how you find the deviation, but you divide it by standard deviation instead of N. Okay. So it's very similar to how you get an average deviation score, but instead of N, you have standard deviation. So this is the formula for your Z score. So when you convert any raw data into Z score, the mean will always be 0 because if you put mean here, let's say for IQ, mean is usually 100 and someone got 100. So no matter what the SD is, the top as in the numerator is going to be 0. So Z is 0. So in any raw data, if we transform it to Z distributions, the mean will always be 0. Hope that is clear. And why is it 0? And usually the standard deviation is expressed in 1. Z score is itself expressed as SD units. And so standard deviation of this entire Z transformation is also 1 SD. Okay, so that is what you get when you have a Z distribution. So characteristics of Z distribution in terms of mean and SD is mean is 0, SD is 1 SD. Okay. So it does not change the shape. So the shape of whatever you had earlier in terms of raw data, so suppose you had a very skewed distribution, will continue to be the same when you convert into a z-score distribution. Fine. Even if it is not symmetric, it will be remaining the same not symmetric shape. If it was symmetric, it will remain symmetric. If it was very flat, it will remain flat, even if you convert to z distribution. Right? So any doubts, questions here? Okay. So what we'll do is we'll have some problems, mathematical problems, so that you, I hope you have understood, because only if you calculate Z score, you'll be able to go forward and calculate other transformations like percentile, right? So percentile is literally how many percentage or area of the curve is under a particular score. Okay. So those things will be discussed in the upcoming one where we discuss normal curve. But before that, let us find Z scores data. So throughout such explanations, I'm going to use IQ as an example because IQ has a very established standard deviation and mean. So in an IQ distribution, usually it is made in such a way that the mean is 100 and standard deviation is 15 for most IQs or IQ tests. There may be some differences. You may have 16, some things may have 20, but ideally for Wetzler based scales, it is 15, right? So I'm going to give you a few scores and I want you guys to transform it into a Z score. So someone had obtained a score of 70 on an IQ test, which has these, what do you call it, statistics. So these features of central tendency and variability. So when you convert 70 to a Z score, what will be the Z score that you get? It's pretty much easy, straightforward one. So what Z score will you get? A, I would say 2 is wrong. So you guys tell me why is 2 wrong? 2 is not the correct answer. Yeah, because you're ignoring the sign. So when you have 70 and the mean is 100, okay, divided by 15, which is a standard deviation, you get minus 30 in the numerator and this is 15 in the denominator. So it is going to be minus 2. So the sign is actually very, very crucial when it comes to Z transformation because that tells you where it is falling. Is it above the mean or below the mean? Okay. So 70 is typically above the, my bad, below the mean, and it corresponds to minus 2 SD. So we'll have a value above the mean. So someone had scored 145, which is considered gifted IQ. So what is their Z score on the same metric? Someone had scored 145. Yes, yeah, 3. So 3 means plus 3, right? So you have 145 minus 100 by your standard deviation 15. It gives you 45 by 15, which is 3 times of 15. So 3. So this means the person is 3 standard deviations above the mean. So this is where I am going to introduce the unit SD. So that score has SD as your unit. So plus 3 standard deviation. That is what you said. So now let's try a slightly different standard deviation. So someone has made an IQ test where the SD is 20 for an IQ test. Okay. So a person has scored 80 and another person had scored 140. Excuse me. So what are these? What are the Z scores of these two scores? X1 and X2. So this is your mean and SD of this particular IQ test. So two people have taken the test. One person has gotten 80, one person has gotten 140. So what is the corresponding Z scores? Good. So this will be -1 SD. Please do mention the standard deviation unit also. And this is how much? X2 is 2 SD. Yeah, I think you guys are pretty much caught up on this. So if you're able to calculate this much, you should be able to calculate much more complex percentiles, area under the curve, and using percentiles, you'll have to calculate the raw scores. Those will be possible when we know the normal distribution or the shape of the distribution. So which is what we will be seeing later. So for now, our main characters have come up with the largest tree in the forest. So they decide to climb it up and see how far they're out. Right? So Freud suggests that he will climb and look at how far they are out. So it seems it is actually pretty far out. So we'll pick up from here in the next class. If you guys have any doubts or questions, do let me know. So we'll be talking about this as a question also. So we do have cognitive checks based on whatever you studied so far in the next class. So do make sure to come up for the next class also after reading, of course. All right. So if you're on YouTube and watching this, so you can easily join this live interactive classes just by logging into the WhatsApp channel. Right? So all the links are in the YouTube description. So you should be able to see it when it is uploaded. Anyone has doubts, questions, anything? Okay, internship. So whatever questions you can shoot. So let's possibly discuss. That'll be a better way. So there are a few questions in the chat. So notes and slides are up for purchase. You can check it on a website. I'll share that in the WhatsApp group, or you can just DM me and I can share it too. So Z-score, inferential or descriptive. Z-score itself is descriptive. Okay, so it still is only describing one single sample. Okay, but it helps us in making inferential comments. So Z-score is literally like what? So your score converted to where it falls compared to the mean. So in terms of true essence, it is an descriptive statistic. Okay. But when you compare two Z scores from two different samples or populations using some sort of a statistical analysis, that is the inferential statistic. So you may have heard of Z test, which is kind of a parametric version for T test. That would be your inferential statistic. Z score alone is not an inferential. Is that clear? Any other questions? Any other thoughts? So also apart from this, we also have something called the Fight Club, which happens scheduled to happen on the weekends. So again, it's going to be a bit interactive, but it is co-construction of content and then challenging each other, right? So we'll be doing it on Saturday. So this Saturdays and Sundays events are actually free for all. So we'll see how we can manage that, because if there are so many people working on the same content, we yeah, same 7, right? So and also for classes apart from CUET-PG, so it is going to be part of paid this. So if you're preparing for Clin.Psy, UGC-NET or it, so consider subscribing to our course. So you should be able to get all the recordings as well as all the interactions and PPTs and notes and stuff. All right, guys. So any other thoughts or questions? So what did you mean when you said SD above and below or Z score on? Okay. So that can be decided by your sign of the Z value. So Z score always has 0 as the mean, any Z transform distribution, right? So if you get a Z score for, let's say, 70 or something on IQ scale, so this would be -2. So this is below the mean. It is not literally up or below in the terms of vertical sense. We are talking about horizontally. So it is below the mean, right? So if you get a score of 140, 145, let's say, this is +3 standard deviation somewhere here. This is considered to be above the mean. So mean is 0. If you get any positive Z score, that means it is above the mean, is on the right side. If you get any negative Z score value, it is below the mean at the left side. And mean is ideally 0. Is this clear? Does this clarify stuff? Okay, so we are introducing basic statistics before we talk about hypothesis testing and all, because we need to know these before we discuss something like hypothesis or maybe even research design. All right. So we'll catch up on those in the coming coming classes. So stay tuned for the links to join the WhatsApp group.